Okay, so number 55. You're driving along at 25 meters per second with your aunt's valuable antiques in the back of your pickup truck when you suddenly see a giant hole in the road 55 meters ahead of you. Fortunately, your foot is right beside the brake and your reaction time is 0. A, can you stop the truck before it falls into the hole? And B, if your answer to part A is yes, can you stop without the antiques sliding and being damaged? The coefficients of friction are coefficients of static friction is equal to 0.60 and the kinetic friction coefficient is equal to 0.30. And our hint here is we're not trying to find the shortest possible distance we can stop in, we're just trying to find the best strategy for avoiding the antiques. So we're going to assume that this giant hole is spanning the entire width of the road, so avoiding the hole by swerving out of the way is not possible. We have to use the brakes in order to avoid this hole. So for part A, can we stop the truck in time? And the answer is kind of no. According to defensivedriving.com, an average car in perfect driving conditions going 60 miles per hour can stop completely in 6.8 seconds. This car is going about 55 miles per hour, so the actual stopping time for that is going to be a little bit less, but based on the information we have, going 25 meters per second and we have 55 meters to stop, we have 2.2 seconds to get this truck to stop moving. So in this situation, it is, and in terms of current automobile technology, it is not possible to stop in time. But so we can practice our knowledge in kinematics and such, we're just going to say yes anyway. So B, can we stop the truck without the box sliding and breaking the antiques? So we have a few pictures here. We have a picture of the truck in the box, and we can see that the motion is going this way in the positive x direction, just to make it simple on ourselves, and this is velocity initial, and the mass of our box is going to be demonstrated as lowercase m since we were not given a value for it. And then our free body diagram of the box in regards to the truck looks a bit like this. We have our static friction and our kinetic friction, and we have the normal force and the force of gravity. The normal force and the force of gravity are going to be equal because the box is not moving in any vertical direction. And we can also see that the coefficients of the 4 different friction forces are different, and the static friction coefficient is greater than the other. And so we need to find if there is an acceleration value that will make stopping in 55 meters possible in general. We need to find that first, and then after that we can see if it's possible to use this acceleration and not break our antiques. So we're going to do this in 2 parts. We're going to solve for the acceleration with the values we have. So we're just going to use a regular kinematic equation here and solve for A. And our final velocity is going to be 0 for when the truck eventually stops. And we find that the acceleration does exist, and it is negative 5.68 meters per second squared. And now we just need to prove that this acceleration will not damage the antiques. We need to find if it is possible to do this without breaking the antiques. And essentially we are going to have to define what acceleration is. So we know from Newton's second law that the force is equal to mass times acceleration. So the acceleration is equal to the force divided by the mass. And we also know that static friction is equal to the static coefficient multiplied by the normal force. And we know in this situation the normal force is equal to the force of gravity. So it's just going to equal mass times gravity. And then in order to get static friction, we're going to multiply that by the static friction coefficient. And so and if we divide by m on both sides, we're going to get this here, and which is eventually going to equal A is equal to the friction coefficient times gravity. And so what we're going to do here is we're going to find a new value of static friction coefficient that will prove whether or not that the damage can be avoided. And so we have quite a lot of math. We're gonna essentially, I can't make this in under 5 minutes. I don't understand.